here. Don't you see me? Oh. Okay. Great. Make sure you guys aren't sitting directly in front or behind someone. You're like diagonal to them. Remember checkerboarding? So you guys are like actually like not within like 4 feet of each other. The university wants me to do. How's everyone's day going? Are we all feeling good? Great. Please don't forget that you guys have homework due on when? When's your first homework due? Great. I love that you guys know that. 8 of you still aren't signed up for WebAssign. I really need you guys to do that. Our rep also reached out to me and let me know that they set up office hours for you guys. I sent you the link yesterday. If you're not getting my emails, check your spam. It might go there. And then you also have, what's it called? Okay. Ooh. Can anyone online hear me?
Yes, I can hear you. Am I not supposed to use the talk feature?
This is what you guys are saying is that screen. I have like 3 things going on.
Okay.
Hold on. There should be a chat somewhere. There's always issues. Okay. So, okay. Okay. Get this all set up. Oh yeah, so if you're having issues with WebAssign, talk to me after class. But yeah. Okay, great. I think I have everything up. So I rushed through some factoring last time, just because I wanted, if you guys wanted to start on your homework now, you can get some formulas. So we're gonna do a quick little review and go through a few of these. Yeah, Mathis. They're on Monday and Wednesday from 12 to 2. If you ever like, oh frick, what are they? They're on the syllabus. And if they ever change, say that like I need to like run somewhere or like do something, I'm gonna let you guys know. But if I don't let you know, the office hours will be what are listed on my syllabus. If you go to our Blackboard on Blackboard Collaborate, then it says like McKinsey's office is like a room that you can visit. All right. So these are notes that were already posted, completed on last Thursday. So I just kind of wanted to review and make sure that we're kind of feeling good with these special product formulas, because they're going to show up more and more as we keep going, right? Math is a lot of building on itself. Okay. So do that in a second. Alrighty. So last time we talked about something called the difference of squares, right? So what that means is I have a squared value minus another squared value. I can then factor that into a plus b, then a minus b, all right? So if we go down here to this first example, I have 4 squared minus 1. I can rewrite that as what minus what? What squared minus what squared?
2x.
Everyone raise their hand and tell me. People in the chat can also tell me. How can I write 4x squared as something squared? Like the quantity squared. Yeah, 2x. Yeah, so I can write it 2x squared minus 1 squared, right? So now I have, you can think of 2x as like your A and 1 as your B, alrighty? So then we can factor this, and what's that factoring gonna look like? How can I factor this? Yeah, 2x minus 1 and 2x plus 1. And if you're ever not sure if that's right, we can always double check ourselves, right? That's kind of the best part about factoring is we already know how to expand. We know how to FOIL. So I can expand out, I can multiply these out, and hopefully I'll get to 4x squared minus 1. All right. So then we also quickly wrote down a squared plus 2ab plus b squared. This one's a little harder to see. It's not like the difference of two square things. So I still have 3 terms. But the hope is that when you see that this number right here, usually, because usually a squared is going to be like x squared something. B squared is going to be a perfect square, right? 64, 81, 9. Kind of should tip off that you should see, check that these guys will hopefully give you something that can factor like this, all right? So if we go look down at 4x squared minus 28x plus 49, well, that's 7 squared right there. That kind of tips me off that I should see if 28x falls into one of these minus 2ab or plus 2ab. Okay, does that make a little bit of sense? Okay, cool. All right, so I know that this just tells me, let's see how I can write this. I can write 4x squared minus 28x plus 7 squared, right? We already said that. Equal. And then, so I have what b squared is. Can I pull out a b from 28x? Can I pull out a 7? Right? I can write this as 4x squared minus 7 times what? What's 28 divided by 7? What? 4, right? 4x plus 7 squared x. I'm kind of going into a little more detail than you might on like a homework or a quiz, but I just want to show this for the purpose of using these formulas to help you out. All right, and then what can I do next to kind of create this either 2 or 3 that I'm looking at? Ooh. We took the 7 and squared it. What about a 4x squared? We just said earlier that we can write that as 2x squared. So I can then factor that out of 4x. So I'm going to have minus 7, 2x, and then we're left with a 2. So I factored a 2x out of this 4x right here, plus 7 squared. Can I use one of the factoring rules from above? Raise your hand if you think I can use one of the factoring rules above. Can someone tell me why? You're right, but why? Yeah, you're exactly right, Malik. Good job. Right? Because I have, if I make B 7 and A 2x, this is the same as 3 up here, right? I have A squared minus, there's a 2, there's B and A. They're a little out of order, but that's fine. Plus a B squared. Right? Then I can go look up here. I'm like, okay, I need to write that as A minus B, that quantity squared. So I'm going to write 2x minus 7 squared. Okay? Not too bad, right? We can get more comfortable with it. All right? So then we quickly moved on to difference in sum of cubes. These are probably my favorite. I don't want you to think that is a subtraction. So, okay. Difference of cubes, a cube number minus another cubed number, x squared minus 8. 8 is 2 cubed. And then sum of cubes, I just add them together, right? So we follow what's called SOAP. The first factor is going to have the same sign, right? So if it's a cubed minus b, I'm then going to write a minus b. And then it's going to be the opposite. So if I had a subtraction, I'm now going to have an addition. And then the last one is always positive. SOAP. Pretty awesome, right? So using difference of cubes and sum of cubes, how can I factor x cubed minus 27?
Can you hear me?
People online can also tell me.
Hello, can anyone hear me?
Recording. Della, like, can you tell me? It's just so weird having. Oh wait. Okay. Hold on. She might be typing, and then you guys can tell me what you're thinking in a hot sec. Okay. Do one of you guys want to tell me how I can factor x cubed minus 27? Right, I can write it as x cubed minus 3 cubed. Is that what you're saying? No, sorry. Did not mean to put words in your mouth. What are you guys thinking? How can I factor x cubed? Yeah.
If you just like identify what A and B are,
Exactly, right? So Abby, right? Is it Ashley? Dang it. I have so many A names. I'm trying to remember them all. What would A be in this case? Well, X, right? So I could write, I already have like kind of like X cubed, right? I can really indicate what A is. And then what would you make B? So we have 3 cubed, right? So all I did is I just rewrote it so that it kind of looks more like something I can play with using the formula of difference of cubes and sum of cubes, right? This one is a difference. I have subtraction. So I'm going to do x minus 3. I keep that sign the same, times a squared, which in this case is just x squared, plus 3x plus 3 squared, which we all know is 9, right? These, when it comes to cubes, these are really good at knowing. Factoring cubes, we're not going to go over long division. It's hard and I don't like it, and I never use it. Factoring cubes can sometimes be really difficult if you don't know these rules. It's not going to be kind of obvious that I can pull out an x minus 3 and then I'm left with x squared plus 3x plus 9. I wouldn't see that right away. Can I reduce x squared plus 3 plus 9 at all? Can I factor that even more? I can't. What do we call that? Let's also remember to wear masks all of class, please. Ooh, someone's wanting to go into class. All right. Yes, irreducible. Can you guys see the chat? Yeah. Okay, great. It's called irreducible, right? I can't reduce it anymore. Perfect, right? If there was a 2 right there, yeah, I just figured out how to factor that a hot second ago, but there isn't a 2. It's just A times B. All right. How are you guys feeling with sum and difference of cubes? Like thumbs up, thumbs in the middle, thumbs down. Okay, we're gonna do this next example then. Alrighty, so now I'm asking you guys to factor 8w to the 6th power plus 125 z to the 3rd. I'll give you guys a second to think about it, and then I would love some help factoring this, if someone can tell me how they would factor this. And just raise your hand whenever you feel comfortable. So what are we thinking? So is it a sum of cubes or a difference of cubes? It's a sum, right? We have a plus right here. So I know that it's eventually going to look like a plus b, a squared plus ab, oops, not plus. What should that be? Minus, and then always plus b squared. So what might help is figuring out what a and b should be. So we can rewrite 8w to the 6th plus 125 z to the 3rd as something cubed plus something else cubed. So let's just focus on 8.
Would you do
Do a little different
2W?
color. Let's do both. Let's just focus on 8w to the 6th first. Do I have a question in the back? Big stretch, okay. How can I write that as something cubed? Mm-hmm. It is going to be 2w squared to the 3rd. How did you get there?
I mean, 2 cubed is 8, and then if you take 6, and you have, I mean, you divide it by 3. And you put 3 on the outside. You multiply it back out, it'll be 8w6.
Right. I can work it back out and I will get 2 to the 3rd times w squared to the 3rd. I get 8. And then we know from exponent rules that if I have 2 parentheses to the 3rd, those multiply, and that's how I get w to the 6th. My computer was on mute. If anyone was talking, I'm so sorry. All right. Okay. Are we good? Perfect. Okay, so I can now, so I know that 2w squared, let's call that a. So then let's look at 125 z cubed. Well, the good thing here is z is already cubed. So I know z, it's just, we're going to be left with just z, right? So 125 is kind of what we're dealing with. It's going to take some time to get used to like the patterns of kind of knowing your cubes. So 125 is 5 cubes. It's kind of obvious. No, that's rude. It's not obvious. It's obvious that it's divisible by 5 because it ends in a 5. That's what I meant to say. So it's a kind of indicator that it is a cube of 5. All right. Perfect. So now I found that I can rewrite. Let's go back to black. There we go. 8w to the 6th plus 125 z cubed as 2w squared to the 3rd plus 5z to the third. Well, now I know sum and difference of cubes, so this makes factoring a lot easier now, right? All right, cool. Is everyone okay online? We're having some technical difficulties. Speak now or hold your keys. Okay. So, I'm gonna scoot this up a little bit. Oopsies. Spoiler alert, don't look at that. I'm gonna scoot this up a little bit. Okay. So I now have my sum of cubes. So how can I factor this? Let me move back a little bit. What's the first one gonna be? So I have my A and I have my B. Oh, I didn't write what B was. Now I have B. So it's the sum of cubes. So the first factor is going to be what? Say it again? Absolutely right. So 2w squared plus 5z, right? Just A plus B. All right. Thank you so much, Malik. All right. So what else can I do? What's the next factor? Anyone?
Would you do 4w to the 4?
Yes. So we're gonna have 4, both of you guys are right, 4w to the 4th, right? Because that's 2w squared squared. That scared the crap out of me.
Wait, me?
Yeah, you're fine. No, it's okay. And then, so we have 4w to the 4th. And then what?
Minus 10w
Minus 10w.
squared.
Thank you, squared. And then what?
Z plus 25 z to the second.
So I have minus 10w squared. Oh, there's a z. Do you mean like that, Carolina? Is that Carolina?
Yeah.
Okay.
Yeah, this is Carolina.
Yeah. Wait. Oops. There is a squared. Sorry. Right. So let me write this a little bit nicer. We got negative 10 because that's 2 times 5 times 2. Right. Hold on. Let me check my notes on that one. I'm pretty sure that's right. Yeah. Wait. Is this supposed to be? 1 second. Zoom in. Yeah. Okay. Perfect. Because there isn't a 2 there. I got confused myself. All right. Are we feeling a little bit better with sum of cubes? Difference of cubes, right? That's kind of what homework for, right? There's homework that I'll be collecting for a grade. And then also if you're like, oh, I still don't feel that good about that homework, there's more practice homework, right? So it's kind of more problems similar to the homework. Some of them at the end are a little bit more difficult at the end of each section. Those are just, right, optional homework is optional. You don't have to do it. It's not a grade. It's just there for practice and for help. What else? I wanted to also say something else about homework and I forgot. Okay. If I remember, I'll tell you. Alrighty. So factoring higher degree, we kind of just saw this when we did something to the 6th. Factoring higher degree polynomials, we can sometimes use a substitution to make our lives 10 times easier. And we've kind of done this already, right? So if I ask you to factor w to the 4th minus 6w squared minus 16, anything after a squared, I'm like, oh, I don't really know how to factor that. That involves like different forms of division that we're not really going to go over. So how can I help myself out? Well, notice that I can rewrite w to the 4th minus 6w squared minus 16 as w squared squared minus w squared, right? So I can kind of make w squared my x. right? And then I can rewrite it as x squared minus 6w. Is that supposed to be minus 16? Yeah. Not w, excuse me. X minus 16, right? I could factor x squared minus 6x minus 16. That's not that bad. I just have to make sure I was given a problem with w's, so I need to give an answer with w's. I can't give an answer in x. You kind of need to translate it back. All right, so that's kind of the key to this. So how can I factor x squared minus 6x minus 16?
X minus 8 and then x plus 2.
Right, so I both heard, yeah, I heard 2 people say x minus 8, and then were you also going to say x plus 2? Remember? Yeah, awesome.
Yeah.
Perfect. Right? Good job, Caroline. Cool. Are we done? No, right? I just said we need to then move back to w's. So all I said earlier was x equals w squared. So we factored. And now we're going to plug in x equals w squared. So I'm going to have w squared minus 8 and w squared plus 2. Can I reduce w squared minus 8 or w squared plus 2? Can I factor those anymore?
No.
Yeah, we can. 8 is not a perfect square. It's perfect cubed, but not a square. So we don't have any of the formulas we had before. I don't see that this is anymore, like we can't factor anymore. So I'm going to call it a done day with those. Alrighty? So that's all we have on factoring. How are you guys feeling with factoring? Thumb scale. We're doing the thumb scale. You can also tell me medium or low. Okay, cool. If you need or want to talk about factoring anymore, I have office hours. Come let me know. Alrighty? So now, guys, look, they're typed. Isn't this beautiful? I spent a really long time doing this. I posted these outlines on notes. If you scroll down on course content, it says skeleton notes. That's what these guys are. And then there's another folder called class notes where I upload the filled in version after class, right? After we've worked through them, okay? So, what section is it? Section B.3 is all about rational expressions. So we kind of talked about rational numbers, but now we're talking about rational expressions. So a rational expression is see if I can fit all this, a fractional expression. Remember, like if you think of like rational, it has the word ratio hidden in there. Ratio is like something over something else. That's what a fraction is. All right. Well, it's an expression now because the numerator and the denominator are both polynomials, right? So some examples we can write like x cubed minus 2 over 3, x squared plus x plus 1 over x cubed plus 8, and so on, right? X to the 100 minus x to the 81st over x squared plus 1. Those are all rational expressions. Okay? So when we simplify rational expressions, we're going to simplify them like how we would reduce a fraction, right? A lot of these rational expression properties are just properties of fractions that we kind of mentioned on our first day of class. So we're going to factor both the numerator and the denominator first, and then we're going to use this property of fractions. So if I have A times C over B times C, how can I reduce that? How can I simplify that fraction? Yeah, the C's are going to cancel out, right? So I'm just going to have A over B. And we also kind of say to the side that C can't equal 0. That'll just mean that I'm dividing by 0, and that's not very cool. And canceling out zeros is weird. Alrighty? So are you guys able to see these? It kind of looks a little fuzzy on my end. No? Damn it. All for nothing. Is that a smidgen better? No. Okay. We're super zooming. I made it like a bigger font for the purpose of this. So if you printed it out, it looks really extremely legible. But I didn't know how it would do on the projector. Okay. Can we at least see what we're working on right now? Okay, great. Thank you. I appreciate all your feedback. In the future, if you guys have access to a printer, I suggest printing these out just to save your little hands writing so fast, and it's so much easier. All right. So we're simplifying x squared minus 1 divided by x squared plus x minus 2. So we need to factor the numerator and denominator and see if anything cancels out. So I'm going to rewrite my function. I'm going to make my pen a little skinnier. Oh, much better. So x squared minus 1 over x squared plus x minus 2. Let's focus on the numerator right now. How can I factor x squared minus 1? Right? This is a difference of squares. I have x squared and I have 1 squared. So I have x plus 1 and x minus 1. Alrighty. How can I then, looking at x squared plus x minus 2, the denominator, I'm not really seeing any fun rule that we just learned, so I think we're just going to have to factor this plain and simple, but that's not going to be too bad. How can someone can raise their hand or throw up in the chat how I would factor x squared plus x minus 2. Your last question of the day.
X plus 2 is x minus 2.
X plus 2, x minus 1, right? Because I get 2 times negative 1, that'll give me a negative 2, and then 2 minus 1 gives me a positive 1. Think if there's like a positive 1 right there. Alrighty. Coolio. Does anything cancel out? Sorry, you can't see that. Right? The x minus 1s cancel out. So I can just draw a little dash through them. So then I'll get x plus 1 over x plus 2. And I'm going to put a box around here because we're done. All right. So now we don't have numbers. Now we're just dealing with A's and B's. Sometimes it's really good to deal with the more like fundamental properties of this rather than worrying about, oh, is this something cubed or not, right? Kind of puts the attention on what I'm doing than playing with numbers. Alrighty. So can I factor B minus A at all? Yeah, it's irreducible, right? It's just a number minus a number. I don't know how to reduce that. What about a squared minus b squared? Yes. Right? And how did you know to do that? How can we look at a squared minus b squared and see that I should factor like that? Kind of the same that we did before, right? We used the difference of cubes, squares. Well, can I cancel anything out? Or can I rewrite it so I can factor something out? Right, I can rewrite it. What should I do? There's lots of different things I can do, and I would love one of your opinions. Oh, yeah. No, you're right. Right here. Perfect, yeah, that's absolutely what I would do, right? So we're gonna leave the numerator alone, so we get b minus a, and then we're not touching a plus b. And then I'm going to pull out a negative, but I'm pulling the negative out of a minus b. So what's that? If I pull out a -1 from a minus b, what's that gonna look like? You wanna tell me? Right, it's gonna flip the subtractions, right? I can also write here. Let me see if I can rewrite this. So a minus b equals negative a plus b, which is the same as negative b minus a. Right, it switches their signs, exactly. Is everyone okay with how I can write a minus b as negative b minus a? Okay, beautiful. Well, great. Now I have, I meant to leave this in parentheses. Great, now I can cancel out b minus a, right? Use my special cancel out marker. And so I'm canceling out b minus a in the numerator. What's that gonna leave me with in the numerator? A 1, right? Okay, good job. Divided by negative a plus b, right? I can also write this as -1 over a plus b. That's totally fine. Negatives have this cool thing where they can float up and down and also on the outside. They can like -1 over a plus b. Alrighty, either of those answers is perfectly fine. Neither one of them is wrong. Alrighty? Cool. Now I'm going to zoom out a little bit, but hopefully not too much. Oh. Okay. I want to see. Okay, we're going to try something. It's going to be crazy. Better? I feel like I'm at the eye doctor. Like 1 or 2. There we go. How are you guys seeing this online? Okay. Can you guys see this a little bit better than you were before?
Yeah.
Okay, thank you guys so much. Okay, Julio, that's fine with me. I like writing a long ways. All right, cool. So we just worked on simplifying rational expressions. So now we're gonna add a little bit more to the front end. So multiplying and dividing rational expressions. I kind of said this earlier. They work the same as they do for fractions, okay? So to multiply a rational expression, I'm going to use the following property for fractions. My paper, okay. So if I have a over b times c over d, I'm going to write that as what? Who can tell me? You're absolutely right. AC over BD, right? Multiplication of fractions is super awesome. because it just multiplies across. So we also have division, right? If we're dividing rational expressions, then I'm going to use the same thing if I was just dividing fractions. If you weren't here on the first day of class, this is called the heap, switch, flip. All right, so if I have a, something is funny in the chat. All right, cool. So A, oh my gosh, divided by B, and then again, divided by C over D. It's like fraction inception. I'm going to keep A divided by B. I'm going to switch the division to multiplication, and I'm going to flip C over D. So now it is D over C. Well, then I'm going to use what I just used above and multiply across. So I get A over D, sorry, A times D over B over C. I think I told you guys this anecdote of I didn't learn how to divide fractions until my senior year of high school. Like was sick that day in algebra. I have no idea how it took me so long. So if you like are struggling with it, do not feel bad. I struggle with it all the time. Okay. Okay. So now we're gonna do a few practice problems just to make sure that we are feeling a-okay with this. All right. So we just reviewed how to simplify. Now we're going to add multiplication and then simplify. All right. So we're asked to multiply, then simplify. You guys can see. X minus 1 divided by x squared plus 4x plus 4 times x plus 2 divided by x squared plus 2x minus 3. There's lots of different steps that you can do, right? You don't have to do one thing first. You can choose to factor and then multiply through. You can multiply through and then factor. It's whatever your heart content is, okay? So, who wants to tell me what they would do first? Ashley.
I'll probably factor at the bottom and see if there's anything like that.
Before multiplying?
Yeah.
Yeah, that sounds like a great idea, right? So we're going to keep these guys separate. So we're going to keep this multiplication. So I'm going to look at x minus 1, x squared plus 4x plus 4. Keeping my multiplication. I'm just rewriting it. To help myself. Okay, cool. All right, and so we are going to factor the denominators, right? NA tors. Whew, long word. All righty. So I'm going to leave x minus 1, right? And x plus 2. Those are irreducible. There's loads of factors I can get. X squared plus 4x plus 4. What are we thinking on this one? How can I factor that? You've answered too many questions. Right? X plus 2 times x plus 2. You can also write x plus 2 squared. I like writing it like this so I can see all the ones I have. Unless it's like x plus 2 to like the 10th, I'm not writing all those out. But if it's just squared, I can write 2 of them. It's fine. Alrighty. And then, so I factored the denominator of the first fraction, or sorry, rational expression. So now I have x squared plus 2x minus 3. So this, I'm focusing on this denominator now. Draw my little parentheses. I know I'm just going to have x on both of them. So two numbers that multiply to -3 and add to 2. x plus 3, x minus 1. Perfect. Awesome. Cool. Now let's multiply the rational expressions, which we are now denoting RE, because that's going to take me way too long to write out. All right, so remember all these are equal. So I'm going to have x minus 1 times x plus 2 in the numerator now. Right? I'm just combining them. Divided by x plus 2, x plus 2, x plus 3, and x minus 1. So what can I do now? Kind of indicated that we need to keep going. So we multiplied. And it says multiply, then simplify. So now we did the multiplication. We did half of it. Now we need to simplify. So we answered all your questions today.
Would you cross out x plus 2 and x minus 1?
You are right, Carolina. So right, I have an x plus 1 here and an x plus 1 here. So I can just knock those guys out. And then I actually have 2 x plus 2's on the denominator, but I only have 1 up top. So I'm going to cancel them out right there. Alrighty? So what's going to leave me in the numerator? 1. Perfect. Oh, my God. Over, and I'm left with just x plus 2, x plus 3. Right? Yeah, okay. Ready? Not too bad, right? So, there we start writing. Okay. Now we're going to do divide. For some reason, I didn't give myself as much space, but I think we'll be fine. So, we're going to divide and then simplify 4 minus x squared divided by 6, then divide by x minus 2 divided by 2. Alrighty? I find it best to do the keep, switch, flip instead of factoring first, just to kind of get the division out of the way and make it look like a multiplication. Alrighty? You don't have to do that. Whatever your heart desires is all, as long as it's mathematically legal in a sense, right? So I'm just going to rewrite this as 4 minus x squared over 6, right? I keep this one, switching to multiplication, and I'm flipping this one, 2 over x over 2. All right? So I'm going to call that keep, switch, flip. I hope that's not something else, something weird. Alrighty? Who wants to tell me what they would do next? Oh. I can multiply straight across, right? So I can have 2, 4 minus x squared divided by 6, x minus 2. Absolutely right. I can then simplify it, help myself out a little bit. 2 over 6, that's just going to be 1 over 3, right? So I'm going to have 4 minus x squared over 3 x minus 2. All right? Can I do anything else? Can I factor the denominator at all? No, right? It's pretty as far as we got. Good job, Delilah. What about the numerator? Right? I see some, yeah. So 4 minus x squared looks like the difference of squares, right? 4 is a square. It's our favorite square. And x squared is also a square, right? So I can rewrite this as 2 minus x and 2 plus x, right? And then I'm keeping my denominator because it says factors that I can be. I'm in that sticky situation again. Dang it, it keeps showing up. Where I have 2 minus x in the numerator and x minus 2 in the denominator. So how can I, once again, rewrite the numerator to help me cancel something else out? Yes. So are you saying, so what I do to the top, I have to do to the bottom. So this is a really interesting case and I like this. So are you saying like -1 over -1 times, here, let me kind of doing like this. No, I like this. I like this a lot, right? So then I'm gonna go below because I ran out of space on the side. Yeah, I did. So I'm gonna put that -1 right here with this 2 minus x, right? Because that'll give me x minus 2, 2 plus x divided by, and I can just attach that -1 to this 3 right here. -3 x minus 2, right? So if you don't see to pull out a -1, you can also multiply by a -1. Just also make sure you're doing the same thing to the top, to the bottom, right? I think I've called this the fancy one. Alrighty. So, great. I did that so that I can cancel out x minus 2, right? So I have those gone. And I can now simplify it to 2 plus x, excuse me, divided by -3. All right. I could also put the negative on the top or on the outside. It can kind of float wherever. All righty. How are we feeling with, what's it called? Multiplication and division of rational expressions. Okay, great. Awesome. Love that. Adding and subtracting gets to be a little bit more difficult just because we need to find what's called the least common denominator. Oh God, is it gonna fit? Wait. Nator. Okay. You guys know what that word is supposed to be. The LCD, right? We need to put both terms over the LCD and then use our favorite property from fractions. If I have A over C plus or minus B over C, I can combine that into one big fraction. I did plus or minus just so I don't have to write a case for subtraction as well. Am I being efficient or lazy? Both. All right, cool. And again, C can't equal 0. We can't divide by 0, right? Okay, cool. How are we doing? On time. Okay. Alrighty, so when we did multiplication and division, we could kind of multiply and divide and then factor the numerator and denominator to kind of help us out a little bit, or not help us out. It kind of didn't matter which one we did first, factoring versus the multiplication or division. For finding the least common denominator, factoring first is probably your best bet. It's probably the kind of what you need to do first, right? I don't like telling you what you have to do first, but it would probably help you out a lot if you factored first. Alrighty. So, and we're kind of only, again, since we're finding the least common denominator, do we need to factor the numerator right away? Probably not. We can just factor the denominator. That's kind of the only thing I'm caring about right now. Luckily, in this example, the numerators are all irreducible. Alrighty? So, can I factor x minus 1 at all? No, right? It's kind of looks like a factor already. And then we said that we aren't going to play with this numerator at all. And then x squared minus 1. Who can tell me what that factors into? Ooh, I heard mumbles. Okay, a little louder, whoever said it. Yeah, you're absolutely right. X plus 1, x minus 1. Great. Okay, cool. So now to the side, we're going to write, oops. I don't know what I'm trying to write. Our least common denominator. There's different ways to find the least common denominator. I don't know what they are. But I want to, oops, should put a 1. I want to multiply the least amount of factors to each thing, right? And I could do x minus 1 plus x plus 1 on this guy, and then x minus 1 on this guy. That would just take a lot of my time, and then I would simplify and factor things out. So that's why finding the least common denominator is going to save us a lot of time in writing, okay? So I have an x minus 1 in my first fraction, and I have x plus 1 and x minus 1 my second fraction. So what is going to be my least common denominator? Can I have some hands? Ashley? Perfect. Why isn't it not just x plus 1? I have to have both. I don't want you to get it confused of what I need to multiply one of them by to then get the least common denominator. It's what kind of this C is, right? They need to match eventually. So what I now have to think about, okay, well, now that I know what my least common denominator is, I need to look at each fraction and see what I need to multiply by to get its denominator to look like the least common denominator. So what do I need to multiply x divided by x minus 1 so that its denominator is x plus 1, x minus 1? Am I going to multiply it by x plus 1 or x plus 1 divided by x plus 1? That one, right? So do x minus 1 times x plus 1 divided by x plus 1, right? Multiplying by a fancy 1 plus, do I need to multiply the second fraction by anything? No, right? It already has, it's lucky enough to have everything in its denominator already. Alrighty? So, multiply. Okay. So when I multiply this across, don't FOIL. I don't want you to get something really long and then have to factor it back out again, right? We're not done simplifying yet. So we want to keep things in factors. So I'm just going to leave this as x times x plus 1 and x minus 1, x plus 1, right? Plus, sorry, my handwriting is turning into trash. Great, can we add these guys together now? Yeah, right? So we're gonna get x plus 1 plus 2x plus 3, ooh, all over x minus 1, x plus 1. What can I do next? Or can I do anything else? What do you mean by cancel? Careful. So that the x plus 1 on the numerator and the denominator. Well, this x plus 1, it is attached to this x by multiplication, but it's not attached to 2x plus 3 by multiplication. They're attached. There's this addition right here. Canceling something out is division. Division and addition don't work together that well. So we actually can't cancel anything out right now, but we can multiply this x through x plus 1 and simplify to see if we can factor the numerator at all. All right, so we're going to do x squared plus x plus 2x plus 3. I'm going to leave the denominator alone. And then I can rewrite x plus 2x as 3x. Can I? X squared plus 3x plus 3. Are there two numbers that multiply to 3 then add to 3? Whole numbers? No. All right. So I'm going to underline this and say done. So we are in fact done. That's as far as we can get. You could stop here, but it's really good to check to make sure that when you multiply those things out, that we're not getting a polynomial that we can then factor and then simplify even more. Okay? So you're just kind of making sure that you're doing the most you can. Oh my God, my computer's on 20%. Oh, 1 second. I want you guys to work on this one while I plug in my computer and see if you guys can figure out what the least common denominator is. And then we'll walk through it. Oh, sorry. Okay. Spooky. Alrighty, who can tell me what they got as the least common denominator and how they got it? And if you're not ready, that's totally fine. Who can tell me what they got for their least common denominator? Ashley, do you want to share? So x plus 1 squared and x minus 1. All right, so Ashley, how did you do that?
For the first
So you got x plus 1, oopsies, times x minus 1 in the denominator for the first one. And then we're lucky enough that the second one is already factored for us, right? So how did you conclude that to get x plus 1 squared, x minus 1? Right, yeah, it's kind of hard to explain it verbally, but like, right, like, so this one has, oh no, I thought I was highlighting and I erased it. I have 2 x plus 1 squares. Both of them in the denominator have an x plus 1. So I know I need at least 1, and this second guy right here is forcing me to have 2. So that's why I have x plus 1 squared, sorry, in my least common denominator. Well, then this first one also has an x minus 1. So then the least common denominator at least has to have that as well. Okay, does that make a little bit of sense? Okay. Coolio. So I'm going to multiply this first fraction by what? What should I multiply it by? To get my least common denominator of x plus 1 squared, x minus 1. Say it a little louder. X plus 1 over x plus 1, right? Yeah. Because if you just tell me x plus 1, that's not allowed. Because what you do to the top, you also need to do to the bottom, right? And then what can I multiply my second fraction by? To get my least common denominator. Yep, perfect. X minus 1 divided by x minus 1. Coolio. We're going to save ourselves some steps. And once we multiply those out and subtract, we're going to get x plus 1. I'm going to attach that negative to 2. So it's going to be minus 2 x minus 1 all over x plus 1 squared x minus 1. Is everyone okay with the 2 steps I just kind of did in one? Sometimes that like doesn't fly. All right, cool. What can I do next? I can kind of simplify just a little bit farther to make my life look a little easier. So x plus 1 is just, those are going to be the same, minus. So when I distribute this 2, I also need to distribute that negative with it. So I'm going to have minus 2x plus 2. That negative 2 times a negative 1 gives you a plus 2. Over, scroll up a little bit, x plus 1 squared, x minus 1. And that's going to simplify to 1 plus 2 is 3. X minus 2x will give me minus x over x plus 1 squared, x minus 1. Let me write that a little nicer. Okay. The reason that I kind of go through and simplify it, again, is just to make sure that the numerator isn't something that I can factor to then simplify again. All right. Okay, I'm going to give you the definition of these, what it means to rationalize the denominator. We have like 5 minutes left, but I want to make sure that we can do an exit slip today. So just going to scroll up a little bit. So if you're still writing, it won't be too bad, right? So if a fraction has a denominator in the form a plus b, then times the square root of c. So like a number plus another number that's times something in the square root. I don't like square roots in the denominator. It's technically not allowed. It's not simplified. We can then rationalize the denominator. We can then move the radical to the numerator by multiplying by something that looks like a minus b times the square root of c. Does anyone know what that's called? All I did is I switched the sign between the a and the b square root c. It starts with a c. Okay, it's called the conjugate. So kind of sounds like spooky. The conjugate. All right. And we'll go into more detail about this next time. But if I'm looking about 1 divided by 1 plus the square root of 2, if I'm just looking at 1 plus the square root of 2, what's its conjugate going to be? Perfect, right? 1 minus the square root of 2. Okay? So all you do is just switch that little sign. If I don't have a square root of all, the conjugate is actually just that number. Fun fact. Alrighty? So, okay, we're going to stop here for today. And we're going to do our exit slip. So, let me open the room. Remember we do our exit slips on Socrative? Our room is black 943, and the last question, also called the teacher question, is give me an example of a rational expression. All right. And once you guys have done that, you are free to go. Right? So how you feeling today, what you learned today, and then answer the teacher question. Everyone at home online can also do the exit slip. Make sure you're following all the directions on the exit slip.
And as long as we do like the exit slip and stuff, if we're at home, we still get counted present, right?
Absolutely.
All right. Thank you.
Thank you, Carolina. Very cool. If you guys have any questions about website, you can ask me them now. So please, 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 please sign up for those. You have homework due, and I really want to make sure that you guys get all the homework grades you can.
All right, so when you go on the website, where do you see the homework at? Because like when I go on the app, I don't see where it's at.
Did you sign up on?
Well, I registered, I got the, whatever the subscription was,
Mm-hmm.
and then I'm in the math 111 classes.
All right, so then, so courses, okay. Oh. I think you clicked onto continue reading. Study tool?
Yeah, I was like looking for the homework or something, but I never saw it. That's why I was
Okay.
confused, because I did the Blackboard one yesterday.
Right, I saw that. Thank you for doing that. Continue reading? Okay, no. Ah, can you get me out of that? I don't know how icons work. Okay.
Or is it different on the computer?
Yeah, I don't know how the phone works.
Okay.
I would
Well,
try on the
can-
computer.
all right, I can
Look at that and then email me.
Okay.
Okay.
I will.
Hi.
I bought a code. for
Okay. Through the bookstore?
the-
Okay.
And I still don't know what to do with it.
Okay. Did you look on the
Yeah, I went to that link and
mhm,
it just wouldn't work.
the link, which one? There's
I think it's the second one.
the one that's on the so okay, hold on. Let me stop sharing my screen so then I can stop share. Okay. So because there is one, so I uploaded like a reminder. So there's there's website information. Did you follow this one?
Yes.
Okay. This one?
Yes.
I know it is kind of confusing. Do you have your laptop with you? Because maybe we can work this out real fast.
I have a just general question. If I have some homework questions, would you rather me ask you them real quick right now or come to office hours tomorrow?
I don't know if there's a class in after. How quick are they? Let's come to office hours tomorrow.
Okay.
So then we can have like 2 hours to talk
That's
if we
fine.
want
I have
to.
a class from 12 to 12:50, so I could probably log on around 1.
Perfectly fine.
Okay.
I'm gonna be in my jams at home.
Okay, that's fine. Because some teachers are like, if no one comes within the first 15 minutes, like I'm closing my office
Oh
hours.
my god, that's so fucking rude. No, I don't do that.
Okay,
I'll just leave Blackboard open and then do lesson planning.
perfect. So I'll just come around that time.
Okay, perfect.
Thank you.
Of course. See if we can figure it out. Oh my god, that's annoying. Library go ahead.
Like, come to Ocean, I was like, it's like 9 degrees. One.